In this video, we'll be starting with a simple quadratic function, f of x. We'll find its inverse function, f inverse of x. Then we'll look at the composition of these two functions. Start by creating a Desmos window. You may want to log in. Graph y equals x, which is a line that crosses the origin and has a slope of 1. The reason for this graph is that functions and their inverses are mirror images across the line y equals x. Now we're ready. So let's start by graphing the function f of x equals x squared. Input f of x equals x squared. This is the graph of a parabola with its vertex at the origin. What does the mirror image of this parabola look like reflected across the line y equals x? Input this equation to see the mirror image. Y squared equals x. To make it easier to see this, turn off the original parabola. This looks like a parabola on its side. But notice it is not a function. Do you see why? This graph does not pass the vertical line test. In other words, a vertical line crossing this parabola would intersect the parabola at 2 points. That is not allowed for the graph of a function. The inverse should basically be half of this parabola, either this half or this half. So let's go back to the original function. Get rid of this non-function and go back to this function. We need to limit the domain of this parabola. Let's limit the domain of this function to values of x greater than or equal to 0. To do so, input this, brackets, x greater than or equal to 0. Now you see only half the parabola. To see the inverse of this function, input g of x equals the square root of x. G of x equals the square root of x. Now you can see the parabolas as mirror images of each other. So the inverse of even the simplest quadratic function needs limits on its domain in order to find the inverse of this function. So f of x and g of x are inverses of each other. In fact, you can write g of x as f inverse of x. What does the graph of f of g of x look like? F of g of x. The graph overlaps the graph of y equals x, but only for values of x greater than or equal to 0. Now look at g of f of x. You get the same graph, the portion of y equals x for values of x greater than or equal to 0. In general, if f of x has inverse function f inverse of x, then the composition of these functions is x. In other words, f of f inverse of x is equal to x.